Hi everybody, today I'm going to go over rules of exponents, and really I'm not trying to teach this, I just want to do some review and practice problems so that you can get better at working with them. So I'm going to real quick go through what the rules are, and there are a bunch of them. So the first one that we call the product rule. So I have x to the n times x to the m, and that's equal to x to the n plus m. Notice in all of these rules that I'm giving you that the base is the same. So we call the base this part that's on the bottom, and then the exponent is up top. Here's the exponent. So the bases are the same. We are adding the exponents. If I do division, again, x, they're the same. I'm going to subtract the exponents. That's called the quotient rule. If I have a base raised to a power that's then raised to another power, then I multiply the bases. This is called the power rule. If I look at x to the negative n, then that is equal to 1 over x to the n. So when I have a negative exponent, I'm going to turn that into a rational, and I just use that exponent as n. So you watch that when I go from the negative exponent into a rational, I'm going to drop the negative sign. That negative was telling me that I need to switch over to this fraction. And then the last one, x to the 0 is equal to 1. So it doesn't matter how ugly the expression is. If it has a 0 power, then I'm going to turn that into 1. We do have one quick note to say that that doesn't work if the base was equal to 0. 0 to the 0 is not equal to 1, so we're not going to write that there. All right, so we're going to start with some examples. I'll start small and I'll get big pretty quickly. So this first one, x to the 9th times x cubed. Well, this is going to be x to the 9 plus 3, which is x to the 12th. The bases were the same, both x, so I add the exponent, 9 plus 3, and I get 12. All right, the next one, I just added more exponents. So I have x to the 4th times x squared times x to the 5th. So it doesn't matter that I have 3 terms now. I'm still going to apply the same rule. I'm going to add 4 plus 2 plus 5. So when I multiply the base, I add the exponent. So 4 plus 2 plus 5 gives me x to the 11th. The next one, I have 2y cubed times 5y to the 6th. So I want you to think about putting the number part together. So I'm just going to group that 2 times 5. And then I'm going to put the y part together. So y cubed times y to the 6th. 2 times 5, we know that's 10. I'm going to add the 3 plus 6. So 3 plus 6 is 9. So here I have 10 y to the power 9. If I introduce a second variable, so this one has x's and y's, I still do that same kind of thing where I think, let's put things together that match. So I have 8x squared y to the 4th times 9x to the 5th y to the 7th. So I'm going to group the 8 and the 9. I'm going to group the x squared and the x to the 5th. And then I'm going to group y to the 4th and y to the 7th. So 8 times 9, 72. I'm going to write this out the long way. So I'm going to say 2 plus 5. And then y, I have 4 plus 7 as the exponent. So this says I have 72, x is to the power 7, y is to the power 11. Let's look at some that have division in them. So we said when we divide, we're going to subtract. So I'm going to start out x to the 8 over x to the 5th. I have x to the 8 minus 5. This gives me x cubed. The next one says x cubed over x squared. Same thing. I say that's x, and I do 3 minus 2. 3 minus 2 gives me 1. When you have the exponent of 1, we usually drop it to say you don't have to have it there. It's extra kind of put it in there. It's not wrong to have it, but it's not needed to have it either, so I'm just going to drop it. Now I have x to the 4th times x to the 5th over x squared. Now, if you think back to your order of operations, like parentheses, exponents, multiplication, division, addition, subtraction, these kind of left to right, left to right. The first one says parentheses, and what I need you to know is there's a hidden parenthesis. So anything in the top is being multiplied together, anything in the bottom is being multiplied together. So even though they didn't write the parenthesis, it's still there. So we still think there's this order of operation that needs to happen, and I would encourage you to put that in to help you remember to do the numerator first, denominator first, and then start messing with it together. I'm going to start out x to the 4th times x to the 5th. I add 4 plus 5. I'm going to leave the x squared alone. 4 plus 5, that's x to the 9th. Over x squared. Now that I've got it down to one term on top, one term on the bottom, now I can say, okay, I know I'm doing the quotient rule, so I'm going to subtract. This gives me x to the 7th. Here's another one. I have w squared times w to the 8th over w cubed times w to the 4th. So I'm going to put in those parentheses to tell myself, simplify the top, simplify the bottom before I try to do anything else. So I have 2 plus 8 as the exponent for the numerator. I have 3 plus 4 for the exponent of the denominator. So 2 plus 8, that's w to the 10th. 3 plus 4, that's w to the 7th. Now I can say, okay, let's do our division. So I'm going to subtract. 10 minus 7 is w cubed. One more, just like that. Z to the 6th times z cubed over z to the 5th times z to the 4th. So 6 plus 3 in the numerator. 5 plus 4 in the denominator. So the numerator is z to the 9th. The denominator is also z to the 9th. So this time, I could go ahead and subtract, right? Let's say we are consistent and keep doing our rules. 9 minus 9, which is z to the 0. And we said z to the 0 would be 1. Now, you could have also noticed that this is the same, z to the 9th over z to the 9th, and you could say that's 1 right there, but I wanted to show you also that I had the 0 exponent, and that's why it becomes 1. Now I'm going to throw in the power rule. So I have x to the 6th to the 7th times x cubed. I'm going to start with the x to the 6th to the 7th. I'm going to multiply 6 times 7, and then I'll multiply by x cubed. 6 times 7, that's 42. And then we'll come back to the x cubed. So now that I took care of this power rule part, now I can do the multiplication part. So this is 42 plus 3, which gives me 45. All right, a little bit bigger. I have x squared to the 10th, and I have x to the 5th cubed. So I need to do the power rule twice. So first I have x squared to the 10th. I'm going to do 2 times 10 as my exponent. I'm going to multiply by x to the 5th cubed, 5 times 3. So I have x to the 20th times x to the 15th. Now I'm into the product rule, so I'm going to add the 20 plus 15. So 20 plus 15 gives me x to the 35th. Here's a little bit of everything. I have the product rule, I have the quotient rule, I have the power rule. What do we do first? Well, we said parentheses and exponent. So there's a parenthesis around the top, let's say parenthesis around the bottom. As I look in the numerator, let's hold on to the x to the 18th and think first I need to square everything. Now, as you're squaring everything, you are distributing to the two terms. So I do have 4 squared, and then I have x to the 5th squared. On the bottom, I have 3 cubed, and I have x to the 4th cubed. And if you think about, like, why did that happen? Because what does it mean? 4x to the 5th squared means I have 4x to the 5th times 4x to the 5th. So I can see the 4 is there twice, the x to the 5th is there twice. So we just wrote it out as an exponent instead. So let's go back to our x to the 18th. 4 squared is 16. X to the 5th squared, we know we're going to do 5 times 2. In the denominator, 3 cubed, 3 times 3 times 3, that's 27. X to the 4th cubed, that's x to the 4 times 3. So we're doing little steps. I'm going to move the 16 to the front. I just like the way that looks better. Let's keep x to the 18th. X to the 5 times 2, that's x to the 10th. And then on the bottom, I have 27, and then this is x to the 12th. Now, I'm using parentheses here and there, sometimes to mean multiplication, sometimes to group. That's really just so I can see it well in my head and so I don't get confused with anything. So don't let the use of parentheses throw you off there. Now I can look at this numerator where I have the product rule still. So I have 16. I have x to the 18th plus 10. I'm doing the product rule. On the bottom, I still have 27 x to the 12th. So this is 16 x to the 28th. 18 plus 10, I have 27 x to the 12th. Now the 16 and 17, they don't have anything in common. No common factors, so I'm not really worried about them. I'm just going to write 16 over 27 and leave the number part alone. I'm putting parentheses, get it out of the way. The x part, I'm going to do 28 minus 12 because I'm doing the quotient rule, so I'm subtracting. So I have 16 over 27. I have x, 28 minus 12 is 16. This is fine. You can write it like this. The coefficient is a fraction, and then I have my variable beside it, or if you like it to be all in one big fraction, I can make it 16 x to the 16 over 27. That works too. Here's another one very similar to that. So I have 12 z to the 5th times z squared to the 8th divided by z to the 6th to the 4th over z cubed to the 7th. So the first 12 z to the 5th, I just want to leave that alone for now. And I want to look at the z squared to the 8th and think I have z to the 2 times 8. I'm going to divide by z to the 6th to the 4th. I write z to the 6 times 4. I'm going to multiply that by z cubed to the 7th is z to the 3 times 7. So what do I have? I have 12z to the 5th. And then I have 2 times 8 is 16. I have z on the bottom. 6 times 4 is 24. And then 3 times 7 is 21. So let's simplify the top. Remember I said it's kind of like parentheses there. So I have 12z. I want to add the 5 and 16, which is 21. On the bottom, I want to add 24 and 21, which is 45. Now I'm ready for the quotient rule. So I have 12z to the 21 minus 45. This gives me 12z. If I do 21 minus 45, I'm going to get a negative 24. We said negatives mean they really belong on the bottom, so I'm going to change that over to 12 over z to the 24th power. So you may be wondering at this point, why do we need these kind of rules? Well, let me give you a really quick example. One place we need exponents is when working with very large or very small numbers. So say we had something like 1,000,000 times 10,000. Those aren't even really big numbers, but they're big enough. If I write those instead as exponents, I would have 10 to the 6th times 10 to the 4th. And we know now from our rules, we're just going to add those exponents. So 6 plus 4 is 10. So I have 10 to the 10th. Now 10 to the 10th looks really nice, right? But let's look at what that looks like if we did keep all those zeros. It would look like this. There would be 10 zeros after the 1, which is a lot to write. It's easy to drop one of the zeros and just make little tiny mistakes. What do we usually do? We would say that number is 10 billion, right? We don't like to write all those zeros. You can see there may be times when you're working with big numbers. Think finances, think of big businesses. They have big numbers that they have to deal with. Or sometimes scientists are working with really small numbers, and that also would make us want to use these rules. So you'll see more of that as you do more studies in math. But for now, I just wanted to give you some indication of why we need this.